Hey guys! Today we're going to move into a super important topic, chemical equations. We're going to learn what they look like and how to balance them. First things first, what is a chemical equation? A chemical equation is a way to describe a chemical reaction using chemical formulas and other symbols. But what does that really mean, and what does it look like? So a chemical reaction takes some chemicals, adds them together, and makes something new. A chemical equation depicts this by taking all of the chemicals that you're going to react together and putting them on the left-hand side, called the reactants side. In this example equation, we're going to take hydrogen gas, H2, and react it with oxygen gas, O2. Now in math class, in an equation, you would usually put an equal sign in the middle. In chemistry, we instead use an arrow called a yield sign. This lets us know which direction the reaction is happening in. On the other end of the arrow, we'll put the product, or the thing that's being produced by this reaction. In the reaction between hydrogen gas and oxygen gas, we're going to get water, or H2O. The right-hand side of the equation is therefore called the product side. In its entirety, this equation would be read as hydrogen gas plus oxygen gas yields H2O, or water. Now that we know what a chemical equation is, we can learn how to balance one. Why is balancing important? Because according to the law of conservation of mass, matter cannot be created or destroyed. To see how this applies to chemical equations, let's take a look at the same reaction as before. H2 plus O2 yields H2O. According to the reactant side, we're taking H2, which is 2 hydrogen atoms, and adding it to O2, which is 2 oxygen atoms, and we're getting out 2 hydrogens, H2, and 1 oxygen. Something doesn't match up there. It seems like we lost an oxygen in that process. This is where balancing is going to come into play. Right now, the equation is unbalanced because there's more oxygen on the left side than there is on the right side. The first step to fixing this problem is just to add more oxygen on the right side, right? To get it balanced. The problem with this is that oxygen isn't one of our products that's listed in the equation. So, instead of adding just 1 oxygen, we have to add an entire water molecule. Now we have 2 oxygens on the left-hand side and 2 oxygens on the right-hand side. However, our hydrogens are now unbalanced. We have 2 on the left and 4 on the right. Lucky for us, this is a pretty simple fix. Since the left-hand side needs 2 more hydrogens for the whole thing to be balanced, all we have to do is add 1 more molecule of hydrogen gas, or 1 more H2. Now we have 4 hydrogens on each side and 2 oxygens. So our equation satisfies the law of conservation of mass and is completely balanced. Scientists did decide, however, that drawing out molecules every time they wanted to balance an equation seemed like a really long process, and for those that weren't quite as good at drawing circles, they decided they'd rather use something else. That something else was numbers, and those numbers are called coefficients. Let's take one last look at our example equation between hydrogen and oxygen. All scientists did, instead of drawing their pictures, was count up how many of each molecule they were going to need to use. So for hydrogen here, we used 2 molecules. So instead of drawing those, they would write 2 in front of their H2. And this big number out in front is called a coefficient. They only used 1 O2 molecule. So instead of writing a 1, they were lazy and just left the 1 out. And they used 2 H2O molecules, so that one had a coefficient of 2 in front of the H2O. So the way this chemical equation, completely balanced, would read is 2 H2 plus O2 yields 2 H2O. And now that we know what balancing is and how to do it, we can do some real quick practice. The accompanying practice page can be found on the HHS Science IPC website, and we're going to be doing problems number 1 and 2. All right, question number 1 is taking C3H8 and some O2 and it's going to yield CO2 plus H2O. To start off with, we're just going to take any element and see if it's balanced. However, you usually want to save hydrogen and oxygen for last, so this time, since the only other element besides hydrogen and oxygen is carbon, we're going to start with carbon. Right now, the left side has 3 carbons, and the right side just has 1. That means the right side's going to need some more. Now we can only add in existing compounds on that side, either CO2 or H2O. Obviously, since we're trying to get more carbon, we should add in more CO2. If we add in 2 more CO2 molecules, then we'll have 3 on each side and carbon will be balanced. The next element I want to look at is hydrogen. You can see that there are 8 hydrogen on the left side and 2 hydrogen on the right. So obviously, the right-hand side is going to need some more hydrogen, which we'll add as H2O. To get the right-hand side all the way up to 8 hydrogens, we're going to have to add 3 more H2O molecules for a total of 4. This means we have 8 hydrogens on the left side and 2, 4, 6, 8 hydrogens on the right side. So hydrogen is also balanced. The last element to check on is oxygen, which is a bit more complicated because it's found in 3 different places, in O2, CO2, and H2O. So far, we only have 2 on the left-hand side. We've got 2, 4, 6, 7, 8, 9, 10 on the right-hand side. So the left-hand side is going to need some more. And we're going to start adding that in the form of O2. So we've got 10 on the right, and we need 10 on the left. Right now we've got 2. We'll make it 4, 6, 8, and 10. Now before we move on and write down our coefficients, we should check to be sure everything's still balanced, because sometimes changing one element's going to throw off another. So let's go through the list again, starting with carbon. Carbon has 3 on the left and 3 on the right. So carbon's good. Then we'll look at hydrogen. Hydrogen has 8 on the left and 2, 4, 6, 8 on the right. And lastly, oxygen has 2, 4, 6, 8, 10 on the left and 2, 4, 6, 7, 8, 9, 10 on the right. So all of the elements are completely balanced. And our last step is to write down the coefficients. You can write down coefficients by counting up the number of each molecule you used. You used 1 C3H8, and we don't have to write 1s as coefficients, so we can just write it as C3H8 plus 1, 2, 3, 4, 5 O2s, and that yielded 3 CO2s and 4 H2O. So your balanced chemical equation is C3H8 plus 5O2 yields 3 CO2 plus 4 H2O. Whew, I know that was a lot, a fairly intense problem. So give yourself a short minute for a breather, pause the video, take a water break, whatever you need, and we're about to move on to problem number 2. Now this problem looks pretty intense, but I promise you it's not too bad. It's aluminum sulfate plus sodium hydroxide yields sodium sulfate plus aluminum hydroxide. It's called a double replacement reaction. So first things first, we're just going to pick any element to balance. And we're going to leave hydrogen and oxygen for last. And I think I'm going to choose aluminum first. So let's look at aluminum on each side. There are 2 aluminums on the reactant side and just 1 on the product side. So what I've got to do to balance that out is add an entire aluminum hydroxide molecule on the right-hand side. Now I have 2 aluminums on the left and 2 aluminums on the right. Those are balanced, and I get to pick a new element. Since we're still leaving oxygen and hydrogen for last, I'm going to choose sodium, which is Na. there's just one Na on the left, and there are 2 on the right. So my left side is going to need some more sodium. To add in that sodium, I'm going to add in an entire sodium hydroxide, NaOH, molecule, so that we have 2 sodiums on the left and 2 sodiums on the right. Those are balanced. My last element that's not oxygen or hydrogen is sulfur, which is S. Now this one's a little bit tricky because on the left side over here, we've got SO3 inside some parentheses, and then another 3 that's on the outside of the parentheses. Now this is really important because it follows the distributive property, like when you multiply something by parentheses in math. So this 3 is going to distribute out to the S, and it's going to make 3 S's there, and it's also going to distribute out to the oxygen and make 9 oxygens, 3 times 3. But right now we're just looking at sulfur, which is S, and you've got 3 of those there on the left-hand side. That's 3 S's. And on the right-hand side, you have just 1. So the right-hand side is going to need more. I'm going to have to add some more of that entire compound, sodium sulfate. And as I'm adding this sodium sulfate, Na2SO3, what I'm going to notice, getting up to 3 sulfurs, is that also changed my sodium, the Na. So now, instead of having 2 sodiums on each side, I have 2 on the left still, but now I have 2, 4, 6 on the right. So what do I have to do? Well, to rebalance my sodium, I've got to hop on over to the left side and add in 4 more sodiums. That way I end up with 6 sodiums on the left and also 6 on the right. So my sodiums stay balanced. Now to do a quick recap there, all we did was add in some more sulfur onto this side to make it 3 and 3, and then we had to rebalance the sodium because adding on more sulfur added on more sodium, putting it out of whack. So now we've done aluminum, we've done sodium, and we've done sulfur. The last 2 are oxygen and hydrogen. I'm going to start with hydrogen, and we're just going to count them all up. So over here on the left-hand side, we've got 1, 2, 3, 4, 5, 6 hydrogen. And on the right, we've got 3 times 1 and another 3 times 1. So 3 plus 3 is 6. 6 and 6 is already balanced. We don't have to change hydrogen. And the very last element is oxygen. So if we take this 3 on the left-hand side that's outside the parentheses, distribute it inside, 3 times 3 is 9. We've got 9, 10, 11, 12, 13, 14, 15 oxygens on the left, and 3, 6, 9. And add another 3 to that is 12. And the last 3 is 15. So we're 15 and 15 on oxygen. Those are both good. Now all the elements are balanced: aluminum, sodium, sulfur, hydrogen, and oxygen. So all that's left to do is write down the coefficients. I'm going to shrink this a little bit so I've got a little more room to write. To put down the coefficients, all we've got to do is count up the number of each compound we used. We had 1 aluminum sulfate, Al2SO3, and when the coefficient's 1, you don't have to write it, plus 1, 2, 3, 4, 5, 6 sodium hydroxides, NaOH, and that yielded 3 sodium sulfates plus 2 aluminum hydroxides, AlOH3. And that there is a balanced chemical equation. Now that you've mastered balancing equations, go get cracking on the last 6 problems of your practice. If you're still struggling after this video and you miss me or Miss Morales, we do have IPC office hours, so check out the links on the website and make sure you get help if you don't know what you're doing.